Hello and welcome. In this video, we'll present a project developed as a part of a bachelor thesis at the University of Agder. The goal has been to design a high-torque, low-speed rotational drive suitable for heavy lifting operations. In offshore industries, there is a constant need for lifting and lowering massive loads, and winches are then a key component in these operations, and they must and can deliver both strength and reliability. Modern winches often consist of multiple small electric or hydraulic motors used to supply a high amount of torque to the winch. The motors are often combined with complex gear assemblies to maximize the torque delivered to the winch. As time goes on, these gears wear down because of the high amount of strain, which then will require frequent maintenance, leading to costly repairs and downtime. To improve reliability and reduce complexity, the concept idea proposes replacing these small motors with a more robust mechanism, a hydraulic cylinder. These cylinders will drive a toothed wheel in a motion similar to a ratchet mechanism, delivering high torque at a low speed and using the hydraulic cylinders as a source to supply torque to the drive wheel. Now let's take a closer look at the components. The system will consist of hydraulic cylinders as an actuator, and this cylinder will be connected to a flipper that is in direct contact with the drive wheel. The rocker arms will make sure that the flipper is in the correct proximity to the drive wheel, and finally the drive wheel that are used to turn the winch drum around. And all of these components will be mounted to an external frame, and for clarity we will simplify these parts into a single representative force. Since the system is using 6 cylinders, the forces will be evenly spaced at 60 degrees, and as you can see, these forces will then be distributed across the drive wheel in a repeated pattern. The drive wheel itself has 36 teeth spaced with 10 degrees in between them. As each cylinder engages, its flipper contacts one specific tooth. So take for example cylinder 1. It engages its first touch on the tooth, which is based on a predefined position of the cylinder. Then we can trace the following touches as the sequence continues and see which teeth the cylinder is in contact with. This continues sequentially for all cylinders up to the number of 6, ensuring an uninterrupted motion. As you can see, each cylinder is in contact with 6 teeth, and this applies for each cylinder to ensure that the drive wheel wears down evenly. When illustrating the sequence of the forces from each cylinder, we visualize how the forces would interact with the drive wheel in a circular pattern. The sequence ensures overlapping engagement, which keeps the system rotating smoothly without any gaps in torque delivery or RPM. To break the system, a flipper release mechanism is created to ensure that the flipper disengages from the drive wheel. Since the drive wheel will rotate in the opposite direction, the cylinder has to accelerate and move faster than the angular velocity. A splint or lever will be placed on the cylinder rub or coupling, and the stopping mechanism on the cylinder housing, such that when the cylinder retracts slightly beyond its normal working stroke, the lever would interact with the flipper, disengaging the flipper from the drive wheel. And once the flipper is free, the cylinder can move forward, preparing to engage with the drive wheel for the braking mechanism. Same as when retracting, the cylinder would extract slightly longer than usual, intercepting additional stopping mechanisms. This stopper will be attached to an external frame and be used to interact with the lever on the flipper mechanism, and the flipper would have a spring force forcing the flipper to move towards the drive wheel and reinitializing contact with the drive wheel. This enables the system to resist rotation by throttling the flow from the cylinder, providing a safe and gradual lowering of the load. As an illustration, this green area is where the cylinders usually operate during a lifting operation, and then the red area is where the stoppers would be placed, ensuring lifting and lowering of the flipper only during a braking season. This concept will use simple mechanical design combined with advanced hydraulic control to research the possibility of an efficient and durable alternative to conventional winch systems. We thank you for watching.